Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Parallel supercomputing is in and of itself almost a branch of mathematical physics, now called extreme-scale computational physics. Without mathematics, computer science becomes computer faith. I had to be a research mathematician to be able to invent the new partial differential equations and the corresponding partial difference algorithms that I discovered. My contribution to mathematics was to discover how to execute them across a new internet. There were two things that I did with my data. First, I copied them from one processor to another processor, and I copied them via email messages. Second, I computed with them at the slow speed of 47,303 calculations per second per processor, and I did so to reach the aggregated speed that was for the first time faster than the speed of any vector processing supercomputer. Put differently, my contribution to extreme-scale computational mathematics did not reside on the processor that was not a member of an ensemble of processors. My contribution to mathematics reside on the processor that is a member of an ensemble of processors and also resides on the entire ensemble itself. Yet, my parallel processing experiment had to wait until the 1980s when 65,536 processors became available for me to experiment with. I said that a petroleum reservoir model that runs on 3 instead of on 4 forces is akin to driving your car on 3 wheels. And with the 4th tire deflated. The lesson that I learned is that you must be a polymath, not a mathematician, to solve the multidisciplinary grand challenge problem that is beyond the frontiers of arithmetic, algebra, and calculus. The reason I could move back and forth from the blackboard to the storyboard is that I am a research mathematician and a research physicist. I knew the 4 forces that define the second law of motion of physics when applied to oil fields, and knew that law forward and backward, and knew how to encode that law into a system of 9 coupled nonlinear, time-dependent, and 3-dimensional partial differential equations of calculus that governs the 3-phase flows of crude oil, injected water, and natural gas that is flowing across an oil field that is a mile deep and that is the size of a town. To solve the Philip Emeagwali equations that are my contributions to mathematics, and do so across a new internet that is a new global network of 64 binary thousand processors, demanded that I discretize the problem domain of the initial boundary value problem. To discretize the problem, I approximated continuous space with discretized space or a finite grid. My new system of partial difference equations of algebra are the discrete versions of my new system of partial differential equations of calculus that I invented. As a research mathematician that is also a research physicist and that is also a research supercomputer scientist, my interdisciplinary knowledge was the necessary tool that gave me the intellectual maturity that I needed to correct the century-old critical errors that I found in calculus textbooks that were written for the petroleum industry. Those errors in calculus found their way from the classroom to the petroleum reservoir simulator used by ExxonMobil Corporation. I should mention that when I discovered that new calculus, or the Philip-Emeagwali equations, I had to create new algorithms that led to new algebra that also codified the second law of motion of physics. Inventing an equation is like making your words a part of the Holy Scripture. The Philip-Emeagwali formula was not for the blackboard alone, nor was it for the motherboard alone. The Philip-Emeagwali formula was invented for parallel processing across my 65,536 tiny computers, or as many processors, that encircled a globe in the way the internet encircled planet Earth. The Philip-Emeagwali formula made the news headlines in 1989 and was highlighted in the June 20, 1990 issue of the Wall Street Journal. 11 years later, that Philip-Emeagwali formula was reconfirmed by then US President Bill Clinton and reconfirmed in his presidential speech of August 26, 2000. The parallel supercomputer is a disruptive technology that gives tech companies some competitive advantage in their drive for market leadership.
Insightful and brilliant lecture.